Tonight we're starting elimination with multiplication. Elimination with multiplication is just like the addition that we did today, except we use multiplication to force one of our variables to have opposite coefficients. We can then add them together to eliminate a variable and solve our system. You will need your multiplication facts for this process. They're critical. Today I also want you to take notes without a guide. I will collect them in class tomorrow for a homework grade. I want to see how you do in taking your notes. Okay, so let's get started with our first example. We're going to start with x plus y equals negative 9 and 5x minus 2y equals 32. As you can see, we have no coefficients that are opposites. We don't even have two coefficients that are the same, so we could multiply one of the equations by negative 1. So instead of multiplying by negative 1 like we did in the previous problems, I'm going to multiply this top equation by 2. When I do that, can you see which variable is going to have opposite coefficients? If you said the y, you're right. When I multiply through, I have to distribute to every term in the equation, remember. 2 times x gives me 2x, 2 times y gives me plus 2y, and 2 times negative 9 gives me negative 18. Now, if I was to graph this line up here and this line right here, I would get lines that coincide or are the same line because they're the same equation. That also means any pair of numbers I put in this equation is going to solve this equation. Okay, so now we are going to disregard this equation for now, and we're going to add the two equations we have left. 5x and 2x gives me 7x. Negative 2y plus 2y is 0. Remember, we're adding. And 32 plus negative 18 gives me 14. I divide both sides by 7. And x equals 2. I now know my value for x, so as we've been doing all along, we go back to that last step that doesn't seem to change, and I'm going to pick this original equation up here because it's a nice easy equation to find my answer. So instead of writing this x right here, I'm going to write 2 because now I know x is 2. Plus y equals negative 9. I'm going to subtract 2 from both sides for a final solution for y to be y equals negative 11. That tells me the solution of my system is 2, negative 11. And if you go back to this equation here and plug that in, if you want to check your work, you would have 2 plus negative 11 equals negative 9, and that is true. I could also check it in this equation because remember, the solution to a system makes both equations true. So I'm going to say 5 times 2, I'm substituting in my x value, minus 2 times negative 11 equals 32. So I get 10. This is a positive. Negative 2 times negative 11 is positive. 22 equals 32. And as you can see, this ordered pair makes both of our equations true. Okay, we're going to look at a more complicated example this time. It is 3x minus 6 equals negative 3 and 2x plus 4y equals 30. As you can see, there's no quick, easy way to make one of the variables match, because you can't multiply 2 by 3 and you can't multiply 4 by anything to get 6. So what I'm going to do is I'm going to multiply the top equation by 2, and I'm going to multiply the bottom equation by 3. Now there are other numbers you could choose to use, but those are the two I chose. They're the smallest ones I could see. So I am going to end up with, can you tell which variables are going to be opposites when I'm done? let's look what happens. 2 times 3x is 6x. 2 times negative 6 is negative 12y equals negative 6. Okay, now I'm going to distribute this 3 to every single term in the second equation, and I'm going to get 6x. Now I'm going to get 3 times 4y is positive 12y. Do you see how I'm going to be able to add to eliminate the y? And 3 times 30 is 90. Now I can add. So you can see why you need to know your multiplication facts, and the better you are with your multiplication facts, the easier it is for you to figure out what numbers to multiply by to make opposite coefficients. I want you to solve the rest with addition. Okay, if you're not done solving with addition in your notes, go ahead and pause the video. We're going to take some more notes and review the steps, and then we're done for the night.
At the end of that first half, Christian Hackenberg, the quarterback for Penn State, took a hard hit on his throwing shoulder. He did get into the locker room, but when he came out to warm up, guys, he was limping in pain. He was fussing with that shoulder. I asked Bill O'Brien, hey, is he okay? He said, oh, he's fine with it. When he saw him looking like that, I did see Bill O'Brien.
Okay, let's review the steps. The first step is to make sure both equations are in standard form. Remember that from when we very first began solving with elimination? Okay, so both equations need to be in standard form. The second step is to select a variable to eliminate. You look for opposites, the same if you could use a -1, or if it's going to be a more complicated process of multiplication before you can eliminate. Okay, so we got it in standard form. We select a variable to eliminate. And then we have to multiply to create opposite coefficients if we don't already have them. So we'll just write multiply if necessary. And we'll write for opposite coefficients. Okay? Then we eliminate a variable by adding. Okay? After we eliminate a variable by adding, we solve for that variable that's left. Once we solve for that variable, we plug our answer, our solution, back in. I'm running out of room. It's a lot of steps, isn't it? Okay? Once you've done that, our final step, and I'm going to put it in a different color to highlight it because it's important. Our final step is check your solution. That is an important habit to get in. Two things. It helps you find careless mistakes you might have made, and on a test it helps prevent losing silly points, and it also helps you understand the process, which makes solving easier in the long run. Alright, so to review our steps. Make sure both equations are in standard form. Select a variable to eliminate. Multiply if necessary to achieve opposite coefficients. We then add to eliminate a variable. Once you have that little equation with only one variable, you can solve for the variable. You take your solution for that variable, plug it back into one of the original equations, and solve for the other variable. Once you have your value for x and y, you need to check your solution. Remember, your notes are due tomorrow. They are a homework grade. Get a good night's sleep. We have a busy day tomorrow. Good night.